The dusty archives of European libraries hold amazing evidence of the past. 16th century maps that will turn your understanding of the size of ancient Russian cities upside down. Imagine unfolding a parchment yellowed by time, created by the hands of a German cartographer 500 years ago, and seeing Moscow, which was 2 or even 3 times larger than Paris and London at that time. Subscribe to our channel, where we reveal the secrets of the past based on scientific facts and modern research. What do you think about the theory of lost areas? Could Russian cities really have shrunk over time, leaving only traces of their former glory? Share your opinion in the comments. Your versions may become the subject of our next investigations. These maps are not unique. In Nuremberg, Venice, Amsterdam, everywhere where the best cartographers of the Renaissance worked, we find the same pattern. Russian cities, especially Moscow, are depicted as gigantic metropolises, dwarfing even the largest European capitals. But how is this possible? After all, modern history tells us that 16th century Moscow was a relatively small city, and the population of the entire Russian Empire did not exceed 10 million people. For a long time, historians preferred to ignore this anomaly or explained it away as mistakes made by medieval cartographers. They said that Europeans knew little about distant Russia and drew cities by eye, often exaggerating their size due to a lack of accurate information. However, upon closer inspection, this version begins to crack. The fact is that Renaissance cartographers were not just artists, but true scientists of their time. Gerardus Mercator, Abraham Ortelius, Sebastian Münster. These people carefully collected information, checked data, and consulted with travelers and merchants. Their maps were used for navigation, trade, and military planning. An error in scale could cost sailors their lives or lead to the failure of a trade expedition. Moreover, the anomaly concerns not only the size of cities, but also their internal structure. On many maps, Moscow is depicted not as a cluster of wooden houses around the Kremlin, but as a city with multiple stone quarters, wide streets, and developed infrastructure. Some maps show a system of canals and waterways within the city, which, according to modern history, never existed. Particularly intriguing is the fact that the increase in size concerns Russian cities in particular. European cities on these same maps are depicted fairly accurately, their sizes corresponding to archaeological data and written sources. Paris is Paris, London is London. But as soon as the cartographer shifts his gaze to the east, the proportions begin to distort in a surprising way. This mystery becomes even more interesting when you consider that different cartographers working in different countries and at different times show roughly the same proportions. It is as if they all drew their information from the same source or saw the same reality, which is radically different from modern ideas about ancient Russia. Today, we will try to unravel this historical mystery. We will trace the path of information from the Russian lands to European cartographic workshops, study the methods of medieval cartographers, and compare map data with archaeological finds and written sources. Perhaps these ancient maps hold a secret that will change our understanding of the history not only of Russia, but of all of 16th century Europe. So, let's embark on a journey through the pages of history, where each map is a witness to its time, and each line on the parchment can overturn established ideas about the past. When we study specific maps closely, the scale of the anomaly becomes truly impressive. Take, for example, the famous map of Muscovy, by Antonius Vetus from 1542. It depicts Moscow as a colossal urban conglomerate stretching for tens of kilometers in every direction. If we are to believe this map, the area of Moscow at that time was at least 300 square kilometers, larger than modern-day St. Petersburg. Even more surprising is the map by Sigismund von Herberstein, an Austrian diplomat who visited Moscow twice in the early 16th century. Herberstein was not an armchair scholar. He personally visited the Russian capital, met with Vasily III, and studied local customs. It is his map that shows Moscow as a gigantic metropolis with multiple rings of fortifications, extensive commercial districts, and a developed river network. These maps show not just an enlarged city, but a detailed urban structure. Moscow is represented as a system of concentric rings. In the center is the Kremlin, then comes Kitai-Gorod, followed by Belgorod, and finally the vast suburbs that stretch to the horizon. Each ring has its own fortifications, gates, and layout features. The image of Moscow's river system is particularly striking. On 16th century maps, we see not only the Moscow River, but also a whole network of canals connecting different parts of the city. Some maps show shipping routes leading directly to Red Square, port facilities in the very center of the city, bridges and crossings where, according to modern history, they never existed. The number of churches and monasteries on these maps is also striking. While modern historians count several dozen churches in 16th century Moscow, maps from that time show hundreds of them. Moreover, these are not just symbolic markings. Many churches are labeled by name, have individual architectural features, and are surrounded by detailed neighborhoods. The density of buildings on these maps corresponds to that of a large European city. We see not wooden houses scattered across fields, but a dense urban fabric with clearly marked streets, squares, and markets. Many buildings are depicted as stone structures, which contradicts the established view of Moscow as a predominantly wooden city. Interestingly, the size of Moscow on these maps correlates with the size of other Russian cities. Novgorod is shown as a huge trading center, comparable to the Hanseatic cities. Pskov is depicted as a powerful fortress with extensive settlements. Tver, Ryazan, and Smolensk are all represented as large urban centers, significantly larger than their modern counterparts. But the most surprising thing is the mathematical accuracy of the proportions. If we take the ratio of Moscow's size to the size of other cities on these maps, we get a fairly consistent picture. Moscow is always 2 to 3 times larger than Novgorod. Novgorod is larger than Pskov, and Pskov is larger than Tver. This hierarchy is repeated on maps by various authors, which suggests that the cartographers relied on specific data rather than simply fantasizing. Moreover, these maps are so detailed that many researchers find objects on them whose existence has only been confirmed by modern archaeological excavations. For example, Herberstein's map shows an ancient trade route through Moscow, which was only discovered by archaeologists in the 20th century. All this forces us to seriously reconsider our attitude toward these cartographic evidence. Perhaps they reflect a reality that was much more complex and larger in scale than we are accustomed to thinking. To understand how seriously we can take this cartographic evidence, we need to get to know the people who created it. The Renaissance was the golden age of cartography, a time when map-making evolved from a craft into a true science. Cartographers of that time were not just artists. They were scientists, mathematicians, and geographers who used the most advanced methods of their time. Abraham Ortelius, creator of the first modern world atlas, Theatrum Orbis Terrarum, in 1570, was not only a cartographer but also a historian, archaeologist, and expert in ancient languages. He corresponded with leading European scientists, gathered information from a wide variety of sources, and carefully checked every detail before putting it on the map. His image of Russia was based on data obtained from merchants, diplomats, and travelers who had personally visited Russian lands. Gerhard Mercator, whose projection is still used in cartography today, developed revolutionary methods of accurate mapping. He was the first to apply mathematical principles to transfer the spherical surface of the Earth onto a flat map. Mercator did not allow for any approximation. Every distance and every angle was calculated with mathematical precision. If Moscow is depicted on his maps at a certain scale relative to European cities, it means that he had specific data for such a representation. Sebastian Münster, author of Cosmographia, one of the most influential geographical works of the 16th century, was a professor of mathematics and ancient Hebrew at the University of Basel. His approach to cartography was exceptionally thorough. He personally interviewed merchants, studied trade records, and analyzed caravan routes. Münster never relied on hearsay or rough estimates. These people worked in an era when the accuracy of maps was a matter of life and death. Sea expeditions, trade caravans, military campaigns all relied on cartographic data. An error in scale or inaccuracy in distances could lead to disaster. Cartographers therefore developed a complex system for verifying information. Information was gathered from multiple sources and carefully collated. If a merchant described the size of a city, his words were verified by other eyewitnesses. Distances between cities were calculated not only from travelers' accounts, but also from the time it took caravans to travel between them, trade records, and diplomatic correspondence. Renaissance cartographers used a single-scale system for the whole of Europe. They knew the exact dimensions of Paris, London, Rome, and Constantinople. These cities served as benchmarks against which the sizes of other settlements were determined. If Russian cities were depicted larger than European capitals, it meant that cartographers had reasons to believe so. It is particularly important to note that many cartographers personally met with Russian diplomats and merchants. In the 16th century, the Russian state actively developed relations with Europe. Russian embassies regularly visited European capitals, and Russian merchants traded in Antwerp, Lübeck, and Nuremberg. Cartographers could obtain information firsthand. In addition, there was a developed system of cartographic exchange. Cartographers bought maps from each other, exchanged information, and corrected their data based on the work of their colleagues. If the image of Russian cities was based on an error or exaggeration, this error would have been quickly identified and corrected by the professional community. The technical capabilities of cartographers of that time should not be underestimated either. They used astrolabes to determine coordinates, applied triangulation to measure distances, and developed complex mathematical formulas to calculate scales. Their tools allowed them to create maps with sufficient accuracy for navigation across the oceans. All this suggests that Renaissance cartographers were serious professionals whose work deserves careful study, rather than being dismissed as medieval fantasies. Where did European cartographers get such detailed information about distant Russia? Lands? This question is key to understanding the accuracy of ancient maps. In the 16th century, there were no satellites or aerial photography, so every line on a map was the result of painstaking data collection from people who had personally visited the places depicted. The first and most important source of information was diplomatic missions. The Russian state under Ivan III and Vasily III actively developed relations with European powers. Embassies were sent to Rome to the Pope, to the Holy Roman Empire to the Emperor, to the German principalities, and to Poland. These diplomatic expeditions lasted for months, with envoys spending weeks and months in European capitals, giving detailed accounts of their homeland. The reverse flow was no less intense. European diplomats regularly visited Moscow. Sigismund von Herberstein was in Russia twice, in 1517 and 1526. His notes contain detailed descriptions not only of Moscow, but also of other Russian cities he passed through. Paolo Hovio, an Italian historian who had never been to Russia himself, interviewed the Russian ambassador Dmitry Gerasimov in detail, obtaining accurate information from him about the size and layout of Russian cities. Trade links were another powerful channel of information. Hanseatic merchants had been trading with Novgorod since the 13th century. Venetian and Genoese merchants reached Moscow via Crimea and the Volga. After the opening of the Northern Sea route through the White Sea in 1553, English merchants established regular communication with Moscow. All these merchants were interested in accurate information about the cities where they did business. Particularly valuable was the information provided by merchants of the Muscovy Company, an English trading corporation that received exclusive privileges for trade in Russia from Ivan the Terrible. Richard Cheslow, Anthony Jenkinson, and Jerome Horsey lived in Moscow for years, studied local customs, and knew the city like their own. Their reports contained detailed descriptions of Moscow's topography. Military intelligence officers were an equally important source of information. In the context of constant military confrontation between the Russian state and its western neighbors, Poland, Lithuania, and Sweden, both sides actively gathered intelligence. The military was interested not only in fortifications, but also in the general layout of cities, population size, and economic potential. Many maps of that time were created specifically for military purposes. Church ties also played a significant role. After the fall of Constantinople, Moscow claimed the role of the center of the Orthodox world. Greek, Serbian, and Bulgarian priests regularly visited Moscow, describing what they saw in detail in letters to their European colleagues. Catholic missionaries, although they received a cold reception in Russia, nevertheless penetrated Russian lands and passed information to Rome. It is important to note the quality of this information. Diplomats were educated people, often knowing several languages and able to read and write. Their reports were intended for kings and emperors, so accuracy was critical. Merchants also could not afford inaccuracies. Their profits depended on a correct understanding of local conditions. Many of these sources duplicated each other, allowing cartographers to verify the information. If an English merchant, a Polish diplomat, and a German traveler independently reported on the large size of Moscow, this gave cartographers reason to trust such information. There was also a system of intermediate informants. Polish and Lithuanian nobles living in border areas regularly received information from Russian merchants and defectors. Crimean and Kazan traders, who did business with both Moscow and European cities, served as a link between the two worlds. Finally, Russian sources should not be forgotten. Many European cartographers had access to Russian maps and city plans. Although most of these documents have not survived, indirect evidence suggests that Russia had a developed cartographic tradition dating back to Byzantine times. The trade routes of the 16th century were veritable information highways. along which knowledge of distant lands spread along with goods. The route from the Varangians to the Greeks, connecting the Baltic and Black Seas via Russian rivers, had been in use for many centuries. But it was during the Renaissance that this route reached its peak. The Volga trade route connected Moscow with the Caspian Sea and further on to Persia and Central Asia. Caravans carrying Eastern goods, such as silk, spices, and precious stones, traveled along the Volga. On the return trip, they carried Russian furs, honey, and wax. Every merchant who traveled this route became a living source of information about the size and wealth of Russian cities. The port of Arkhangelsk, opened to European trade after the voyages of Richard Chancellor, played a particularly important role. The Northern Sea route allowed English, Dutch, and German merchants to reach Russian lands directly, bypassing hostile Poland and Lithuania. Arkhangelsk became the gateway through which Europe got to know Russia. The English Muscovy Company established a whole network of trading offices in Russian cities. Their agents lived in Moscow, Yaroslavl, Vologda, and Kolmogorye. These people did not just trade. They studied local conditions, compiled reports on population numbers, described urban planning, and assessed the economic potential of regions. German merchants from Lübeck and other Hanseatic cities had a long tradition of trade with Rus. Their representative offices in Novgorod existed for centuries. After Novgorod was annexed to the Muscovite state, these trade links were not severed but, on the contrary, expanded. German merchants gained access to Moscow's markets, and their reports added to European knowledge about Russia. Venetian and Genoese merchants used southern routes through the Black Sea and Crimea. Kaffa, modern-day Feodosia, was an important transshipment point where European and Russian merchants met. Italian merchants were able to compare the size of Russian cities with well-known European centers. But trade links were only part of the picture. Military intelligence played an equally important role. The Livonian War, which lasted from 1558 to 1583, required all participants to have detailed knowledge of enemy territory. Polish, Swedish, and German military leaders sent numerous agents to Russian lands. These scouts were interested not only in military targets, but also in the general condition of cities. Population size, economic potential, and transportation capabilities were all critically important for planning military operations. Many European maps of that time were created by military cartographers based on intelligence data. Cossack troops, who served sometimes the Moscow Tsars, sometimes the Polish kings, and sometimes the Turkish sultans, were another source of information. The Cossacks knew the geography of Eastern Europe very well. They could compare the sizes of different cities and assess their defensive potential. Information from the Cossacks reached all European capitals. Religion also played a big role. After the fall of Byzantium, a lot of Greek priests and monks found refuge in Russia. They kept in touch with fellow believers in Europe, regularly writing to Orthodox communities in Venice, Vienna, and other European cities. Their letters had detailed descriptions of Russian cities and monasteries. Diplomatic intelligence was particularly well developed in Poland and Lithuania, Russia's main western neighbors. Polish magnates had extensive estates in the borderlands, and their agents regularly penetrated deep into Russian territory. Lithuanian princes, many of whom had family ties to the Russian nobility, obtained information through family channels. Despite constant wars with Russia, the Crimean Khanate maintained trade relations with it. Crimean merchants regularly visited Russian cities, especially those in the south. Through Crimea, information about Russia reached the Ottoman Empire and, from there, to Europe. It is important to note that all these sources of information worked in both directions. Russian diplomats, merchants, and spies also gathered information about European cities. This created an opportunity for comparative analysis. If a Russian ambassador who had visited Paris claimed that Moscow was larger than the French capital, this gave European cartographers a concrete reference point for scaling. The information gathering system was so well developed that European rulers often knew about events in Russia before they knew about similar events in neighboring European countries. This indicates the high intensity of information exchange and, accordingly, the high reliability of the data obtained. Modern archaeology can give us an objective view of the size of ancient cities, regardless of written sources and cartographic evidence. Excavations in Moscow, which have been going on for over a century, reveal an amazing picture that largely confirms the data of ancient European maps. Archaeological research shows that the cultural layer of 16th century Moscow extends far beyond the boundaries of the modern Kremlin and Kitai-Gorod. Finds of ceramics, metal objects, and remains of wooden structures have been discovered over a huge area, from Sokolniki in the north to Kolomenskoye in the south, from Filey in the west to Lefortovo in the east. The results of excavations on Red Square and in its vicinity are particularly interesting. Here, archaeologists have discovered the remains of an ancient system of canals and aqueducts that correspond exactly to the images on 16th century maps. These canals were filled in at a later date, but their traces have been preserved in the soil. It turns out that European cartographers knew more about the existence of Moscow's water system than historians of the 19th and 20th centuries. Excavations in the Zaryadye area have uncovered the remains of an extensive commercial district with cobbled streets, stone foundations of houses, and traces of craft workshops. The scale of these finds suggests that the commercial part of Moscow was much larger than previously thought. Archaeologists have found coins from various European countries here, confirming intensive trade links. Research in the White City has also yielded unexpected results. The cultural layer here turned out to be much older and more powerful than expected. This means that the area of modern central Moscow was already densely populated in the 15th to 16th centuries. The finds include the remains of stone buildings, which contradicts the image of Moscow as a purely wooden city. The results of the excavations of monasteries are particularly impressive. The Novospassky, Danilov, and Novodevichy monasteries all show traces of much earlier and more extensive construction than written sources indicate. Archaeologists are finding the foundations of churches and cells that are not mentioned in the chronicles but are present on European maps of the 16th century. Dendrochronological analysis of wooden structures found during excavations shows massive construction in Moscow in the late 15th and early 16th centuries. This was the period of the reign of Ivan III and Vasily III, when, according to European maps, Moscow reached its maximum size. Excavations in Zamoskvorechye have uncovered the remains of extensive craft settlements. Kilns for firing ceramics, blacksmiths' forges, and weaving workshops have been found here. The number and variety of craft industries indicate that this part of Moscow was much more developed than previously thought. Research shows that Moscow's fortification system was much more complex than traditional sources describe. Archaeologists have discovered the remains of earthen ramparts and moats that surrounded the city in concentric rings at a great distance from the center. These fortifications correspond exactly to the images on European maps. Findings in the field of transport infrastructure also support the data from ancient maps. Archaeologists have discovered the remains of paved roads, bridges over streams and ravines, and drainage systems. All this points to a high level of urban planning and the considerable size of the city. Analysis of the finds shows a high population density in the territory of ancient Moscow. The number of pottery shards, metal objects, and food remains in the cultural layer corresponds to a large urban center with a population of several 100,000 people. The finds of imported goods are particularly important. Archaeologists have discovered ceramics from Germany, glass from Venice, fabrics from Flanders, and coins from various European countries in 16th century Moscow. The number and variety of these finds indicate intensive international trade, which required an appropriate urban infrastructure. Radiocarbon analysis of organic remains confirms the dates obtained by other methods. The peak of Moscow's development did indeed fall at the end of the 15th and beginning of the 16th centuries, just when European cartographers depicted it as a gigantic city. A comparison with archaeological data from other Russian cities shows a similar picture. In Novgorod, Pskov, and Tver, archaeologists have found traces of more extensive construction in the 16th century than was assumed on the basis of written sources. Russian chronicles are a unique source of information about the size and layout of ancient cities. However, a curious feature emerges upon closer examination of these texts. Many chronicle accounts of the size of cities mysteriously agree with European maps, rather than with modern ideas about history. The Laurentian Chronicle, describing the events of the 16th century, mentions the great city of Moscow, which stretches from river to river. If we take this literally, we are talking about a city occupying the space between various rivers in the Moscow region, the Moskva River, the Yauza, and the Neglinaya. Such dimensions do indeed correspond to the images on European maps. The Nikon Chronicle mentions the construction of many stone churches in Moscow, the total number of which is estimated at hundreds. The chronicler notes that there were countless stone and wooden churches in the city. This is consistent with the images on the maps of Herberstein and other European cartographers, which show hundreds of churches in Moscow. Particularly interesting are the records of fires in Moscow. The chronicles regularly report on huge fires that destroyed the entire city from end to end. Descriptions of these disasters indicate that the fire spread over vast distances, engulfing multiple areas. Such large-scale fires are only possible in a very large city. The Chronicle of the Fire of 1547 reports that the fire burned all of Moscow and the Kremlin and Kitai-Gorod and Bely-Gorod and many settlements beyond the Moscow River. If you add up the areas of all these districts, you get a territory comparable in size to Moscow on European maps. Records of the construction of fortifications also give an idea of the city's size. The chronicles mention the construction of many versts of ramparts and moats around Moscow. The work continued for years and required the participation of many thousands of people. Such construction volumes testify to the protection of a truly large urban center. Descriptions of commercial activity in the chronicles are striking in their scale. There are mentions of great marketplaces where merchants from many lands converge. Chronicle writers write that in Moscow there were countless goods of all kinds, and that the market stalls stretched from morning till evening. Such commercial activity required an appropriate urban infrastructure. The data on population contained in the chronicles also deserve attention. Although exact figures are rarely given, indirect indications suggest large numbers. For example, the chronicles mention that during epidemics in Moscow, many tens of thousands of people died. This is only possible with a very large total population of the city. Records of military events contain information about the mobilization of multitudes of warriors from Moscow and the surrounding area. The chronicles say that the Moscow regiments consisted of tens of thousands of horsemen and foot soldiers. Such military contingents could only have been assembled from a large area with a high population density. Descriptions of religious processions and celebrations also give an idea of the size of the city. The chronicles report on religious processions that lasted from morning till evening, covering the entire city. Participants in the processions walked many miles, visiting many churches and monasteries. The chronicle descriptions of the reception of foreign ambassadors are especially valuable. Russian chroniclers proudly noted that European diplomats marveled at the great city of Moscow, and that they had never seen such a great city before. These records are consistent with the impressions reflected in European maps. The chronicles also contain information about other Russian cities that support the overall picture. Novgorod is described as a great trading city, Pskov as an impregnable fortress, and Tver as a populous city. All these characteristics correspond to the images of cities on European maps. It is interesting that the chronicles often mention comparisons between Russian cities and European ones. The records say that foreigners compared Moscow to the greatest cities of the West, that it was no smaller than Paris or London. Such comparisons could have served as the basis for corresponding images on maps. An analysis of chronicle terminology shows that old Russian chroniclers distinguished between city in the narrow sense, fortified center, and city in the broad sense, the entire urban complex with settlements and suburbs. When the chronicles refer to the great city of Moscow, they apparently mean the entire urban complex, which explains its large size. The notes of European travelers who visited Russia in the 16th century are an invaluable source of information about the actual size of Russian cities. These people were contemporaries of the events. They personally saw what they described, and their testimonies deserve the most serious attention. Sigismund von Herberstein, an Austrian diplomat who visited Moscow twice, left the most detailed description of the Russian capital. In his Notes on Muscovy, he writes, "Moscow is so large that it takes a whole day to walk from one end to the other." Herberstein compares Moscow to Vienna and claims that the Russian capital surpasses the Austrian capital in size by 2 or 3 times. Herberstein was particularly struck by the number of churches in Moscow. He writes, "There are so many churches in the city that it is impossible to count them. Wherever you look, you see domes and crosses." According to his calculations, there were more than 200 churches in the part of the city that he was able to walk around, and he admits that he did not see the whole city. Pavel Jovi, an Italian historian who had never been to Russia himself, interviewed the Russian ambassador Dmitry Gerasimov in detail. As a result of these conversations, he compiled a description of Moscow that is striking in its scale. Jovi writes, "Moscow is the greatest city of the north, surpassing in size all the cities of Germany and Poland known to us." English navigator Richard Cheslaus, who discovered the northern sea route to Russia, was shocked by the size of Moscow. In a letter to the English king, he reports, "This city surpasses London in both size and number of inhabitants. It takes more than a day to cross it from end to end on horseback." The notes of merchants from the Muscovy Company, who lived in Russia for years, are especially valuable. Anthony Jenkinson notes in his diary, Moscow is a city of amazing size. I have traveled through many European capitals, but nowhere have I seen such a vast urban settlement. He describes in detail the various districts of Moscow, mentioning that each of them is inhabited by a multitude of people. Jerome Horsey, who lived in Russia for 17 years, left detailed notes about life in Moscow. He writes, "Moscow amazes even those who are accustomed to large European cities with its size. Its suburbs stretch for many miles in all directions." Horsey mentions that in Moscow there are more craftsmen and merchants than in many European kingdoms. The notes of Polish diplomats who regularly visited Moscow in connection with frequent negotiations between the two countries are interesting. Polish ambassador Jan Laski writes, "Moscow surpasses Krakow and Warsaw combined. This city stretches further than the eye can see from the highest tower." German merchants who traded in Russia also left evidence of the size of Russian cities. Konrad Busso, a merchant from Lübeck, writes, "There are so many people in Moscow that it is difficult to push your way through the markets. The rows of shops stretch for many hundreds of steps, and merchants come from all corners of the world." Foreigners were particularly impressed by Moscow's monasteries. French traveler Jacques Marcheret notes, "There are so many monasteries in Moscow and its environs that they would be enough for an entire kingdom. Each monastery is surrounded by extensive estates and has many churches." Venetian diplomat Ambrogio Contarini, passing through Moscow on his way to Persia, wrote, "Moscow is the greatest city I have seen in the northern lands. Its size is comparable to Constantinople, and its population exceeds that of many Italian cities." Swedish diplomats, despite the hostile relations between Sweden and Russia, also recognized the size of Moscow. Ambassador Peter Petre wrote, "Moscow is so large that our northern cities seem like villages next to it. It has more people than the entire Swedish kingdom." The traveler's notes also contain information about other Russian cities. Novgorod is unanimously described as a great trading city. Pskov amazes them with its fortifications. This fortress is stronger than many European ones. Tver is described as a populous city with large settlements. It is important to note that all these travelers were educated people. Many of them knew several languages and had experience traveling in Europe. They could compare the size of Russian cities with European ones, and their assessments were based on personal experience. Many of these notes were intended for the rulers of European countries, so the authors could not afford to exaggerate. False information would have been quickly discovered when compared with other sources. The fact that independent witnesses from different countries give similar estimates of the size of Russian cities speaks to the reliability of their testimony. To understand how accurate the data on city sizes in the 16th century could have been, it is necessary to understand the measurement methods used at the time. The Renaissance was a period of revolution in science, including geodesy and cartography, and methods of measuring distances had reached a fairly high level of accuracy. The main tool for determining distances was triangulation, a method based on measuring the angles of triangles. Surveyors of the time used astrolabes and quadrants to accurately determine the angles between different points on the ground. Knowing the length of one side of the triangle and the angles, it was possible to calculate all other distances with high accuracy. Special measuring chains and ropes were used to measure base distances. These instruments were calibrated against standard measures of length that were kept in large cities. The accuracy of such measurements was quite high, with errors usually not exceeding 2 to 3%. even over long distances. Renaissance cartographers developed complex mathematical methods for translating real distances to map scale. Gerhard Mercator, for example, used logarithmic calculations to create his famous projection. Sebastian Münster used algebraic formulas to calculate the areas of cities based on the perimeter of their walls. Astronomical methods of determining coordinates played a particularly important role. Cartographers used observations of the sun and stars to accurately determine the latitude of various points. Longitude was more difficult to determine, but methods based on observing lunar eclipses and other astronomical phenomena were also available. Various approaches were used to measure the size of cities. The simplest was to determine the time it took to cross the city on foot or on horseback. This method gave approximate results, but when used correctly, it could be quite accurate. The average speed of a pedestrian is about 4 kilometers per hour, and that of a horseman is about 8 to 10 kilometers per hour. A more accurate method was to count steps. Experienced surveyors could measure distances quite accurately by counting their steps. This method was widely used by Roman surveyors and was improved during the Renaissance. Professional surveyors calibrated the length of their steps and could determine distances with an accuracy of a few percent. The geometric approximation method was used to determine the area of cities. The city was divided into simple geometric shapes: triangles, rectangles, circles. The area of each shape was calculated separately, and then the results were added together. This method provided quite acceptable accuracy for cartographic purposes. Comparative measurements played an important role. If a cartographer knew the exact dimensions of one city, he could use it as a reference for determining the dimensions of other cities. For example, knowing the size of Paris, it was possible to estimate the size of Moscow by comparing the time it took to cross each city. Cartographers also used population density data to estimate the size of cities. Knowing the approximate number of inhabitants and the average building density, it was possible to calculate the total area of the urban territory. This method required a good knowledge of local conditions, but could give fairly accurate results. Measurements based on military engineering data were particularly accurate. Military engineers of the time had to know the distances precisely in order to plan sieges. Their measurements were highly accurate, as the success of military operations depended on them. Trade records were also a source of data on the size of cities. Merchants knew exactly how long it took to deliver goods from one part of the city to another, the distances between commercial districts, and the size of markets. This information was used by cartographers to refine their data. Methods of accuracy control were also quite advanced. Cartographers compared data obtained by various means and, in case of discrepancies, carried out additional measurements. The results of one cartographer's work were checked by colleagues, which made it possible to identify and correct errors. It is important to note that Renaissance cartographers understood the difference between different types of measurements. They distinguished between the size of city fortifications, the area of built-up territory, and the total area of the urban district. This terminological precision helped to avoid confusion when interpreting data. The system of units of measurement was fairly standardized within Europe. Most cartographers used Roman miles or German leagues, which made it possible to compare data from different authors. Conversion factors between different systems of measurement were well known and widely used. During the Renaissance, maps served not only practical purposes for navigation and trade, but also had an important symbolic function. The size of a city on a map often reflected not so much its physical parameters as its political significance, economic power, and cultural importance. This principle of symbolic cartography may explain why Moscow was depicted on European maps as being so large. Moscow's political significance in the 16th century was indeed enormous. Under Ivan III and his successors, the Russian state expanded rapidly, annexing new territories and becoming one of the largest powers in Europe. By the middle of the 16th century, Russia controlled territory from the White Sea to the Caspian Sea, from the Baltic to the Urals. The capital of such an empire was naturally perceived by Europeans as a city of exceptional importance. Moscow's economic role was also enormous. Trade routes connecting Europe with Asia passed through the Russian capital. Moscow merchants traded with China and Persia, India, and Central Asia. The riches of Siberia, furs, precious metals, ivory, flowed into Moscow. For European cartographers, a city that controlled such trade flows deserved to be depicted accordingly. The religious significance of Moscow increased many times over after the fall of Constantinople in 1453. The Russian capital claimed the role of the Third Rome, the center of the Orthodox world. This claim was not merely an ideological declaration. Moscow truly became a spiritual center for millions of Orthodox believers from the Balkans to the Far East. Renaissance cartographers were well aware of the symbolic significance of their works. A map was not just a technical document, but also a political statement. The size of a city on a map could reflect respect for its ruler, a desire to establish trade relations, or recognition of its international status. The principle of hierarchical representation was widespread in medieval and Renaissance art. In religious paintings, the size of a figure reflected the holiness of the character. In portraits, social status, and in battle scenes, the importance of the military leader. Cartography borrowed this principle, using size to convey the significance of geographical objects. A comparison with images of other cities confirms this theory. Rome on 16th century maps is often depicted larger than its actual size, reflecting its status as the center of the Catholic world. Constantinople is shown as a huge city, corresponding to its role as the capital of the Ottoman Empire. Paris and London are depicted in proportion to their political influence. However, symbolic explanations have their limitations. If cartographers were guided solely by political considerations, the sizes of cities on maps by different authors would vary considerably, depending on the nationality and political sympathies of the cartographer. But we see remarkable unanimity in the depiction of Moscow's size by German, Italian, Dutch, and English cartographers. Moreover, the detail of Moscow maps suggests that cartographers had specific information about the internal structure of the city. Symbolic representation is usually limited to general outlines, but on maps of Moscow, we see detailed work on individual districts, streets, and buildings. Such detail requires real data, not just symbolic representations. An analysis of cartographic tradition shows that the principles of symbolic representation were mainly applied to little-known or mythical places. Well-known European cities were depicted fairly accurately, as errors were easily detected and undermined the cartographer's reputation. By the 16th century, Moscow was fairly well known in Europe thanks to its trade and diplomatic ties. The economic interests of cartographers also argue against a purely symbolic approach. Maps were expensive items bought by merchants, diplomats, and military personnel, people who needed accurate information. A map with obviously inaccurate data would quickly lose its commercial value. Religious maps, created to illustrate biblical scenes or the lives of saints, did indeed often use symbolic principles, but secular geographical maps of the 16th century strove for maximum accuracy within the limits of available technical capabilities. Perhaps it would be more accurate to speak of symbolic emphasis rather than symbolic distortion. Cartographers could emphasize the size of truly large and important cities without distorting the overall geographical picture. Moscow could be depicted larger than less significant cities, precisely because it was larger and more important. Nevertheless, the factor of symbolic cartography cannot be completely ruled out. It could have influenced the choice of which details of the city to show on the map, how to arrange the inscriptions, and what symbols to use to designate various objects. But it is unlikely that this factor could have radically distorted the perception of the city's size. One possible explanation for the abnormally large size of Moscow on European maps may be systematic errors in the transmission of information from sources to cartographers. In the 16th century, information was transmitted orally through many intermediaries, and distortions could occur at each stage of transmission, which accumulated and ultimately led to significant discrepancies with reality. Language barriers posed a serious problem for the accurate transmission of information. Russian merchants and diplomats communicated with Europeans through interpreters who did not always accurately understand technical terms related to the measurement of distances and areas. The Russian concept of a city could include not only a fortified center, but also extensive suburbs, which could be misinterpreted when translated into Latin or German. Differences in measurement systems could also lead to errors. Russian versts, sajans, and other measures of length had no exact equivalents in European measurement systems. Translators and informants could use approximate equivalents, which, when accumulated, resulted in significant errors. For example, if a Russian verst was translated as a Roman mile, this resulted in an error of about 1.5 times. Psychological factors also played an important role in distorting information. Travelers, finding themselves in unfamiliar surroundings, tend to exaggerate the scale of what they see. Moscow, with its architecture, layout, and way of life unfamiliar to Europeans, could give the impression of being a much larger city than it actually was. Social motives could influence the nature of the information conveyed. Russian informants could deliberately exaggerate the size of their cities out of national pride, or to intimidate potential enemies. European travelers, returning home, could describe what they saw in colorful terms to impress their listeners. The technical illiteracy of many informants also contributed to errors. Not all merchants and diplomats were able to accurately measure distances or estimate areas. Their estimates were often based on subjective impressions, which could differ significantly from objective measurements. The system of transmitting information through intermediaries created multiple opportunities for errors. Information could be passed down a chain. A Russian merchant would tell a Polish trader, who would tell a German colleague, who would then pass the information on to a cartographer. Inaccuracies and distortions could arise at every stage. Time factors also affected the accuracy of information. Descriptions of cities could refer to different periods of time, and cartographers did not always take these differences into account. Moscow did indeed grow very rapidly in the 15th and 16th centuries, and descriptions made several decades apart could differ significantly. Selective perception meant that informants focused on the most impressive aspects of cities. A large number of churches, extensive markets, and numerous fortifications could all create an impression of a city that was larger than it actually was. The lack of standardized methods for describing cities also contributed to errors. Different people could understand city size to mean different things. The area of fortifications, the total built-up area, or administrative boundaries. This terminological confusion could lead to incorrect comparisons. The commercial interests of informants could influence the nature of the data they provided. Merchants were interested in presenting Russian cities as large trading centers capable of absorbing large volumes of European goods. This could lead to conscious or unconscious exaggeration of their size. Political motives could also distort information. In the context of complex international relations, the size of enemy cities could be exaggerated to justify the need for large military preparations, or, conversely, to explain failures in military campaigns. However, the theory of information transmission errors faces serious objections. First of all, the remarkable unanimity of various sources in assessing the size of Russian cities is difficult to explain by random errors. If the distortions were chaotic, we would see a wide range of estimates, not a consistent picture. In addition, many European informants were educated and experienced enough to give relatively accurate estimates. Diplomats underwent special training. Merchants had extensive experience in assessing cities for commercial purposes, and military personnel had professional intelligence skills. The system of information verification that existed in cartographic circles should also have identified gross errors. Cartographers compared data from various sources, consulted with colleagues, and checked new information against existing maps. Finally, archaeological data in many cases confirms the information on old maps, which argues against the theory of mass errors in the transmission of information. If European maps were based on distorted data, they could not have reflected the real topography of Russian cities so accurately. To fully understand the anomaly with the size of Moscow on European maps of the 16th century, it is necessary to consider how other Russian cities were depicted, as well as to compare them with European urban centers of that time. Such an analysis will help determine whether the problem was systematic or specific to Moscow. Novgorod is depicted on European maps as a large trading center comparable in size to Hanseatic cities such as Lübeck or Hamburg. This corresponds to its historical status as one of the most important trading hubs in Northern Europe. Archaeological research confirms that medieval Novgorod was indeed a large city, with a developed craft and trade infrastructure. Pskov is shown on maps of that time as a powerful fortress with extensive settlements. Its size exceeds that of many European cities of a similar type. Modern research into Pskov's fortifications shows that the city did indeed have one of the most sophisticated defensive systems in Europe, and its commercial and craft quarters extended far beyond the walls of the Kremlin. Tver is depicted on European maps as a significant urban center, which corresponds to its role as the capital of one of the largest Russian principalities. Although Tver lost its political significance after its annexation to the Muscovite state, its economic position at the intersection of important trade routes preserved its status as a major city. Ryazan is shown on maps as an important outpost on the southern borders of the Russian lands. Its size reflects the strategic importance of the city as a center for fighting nomads. Archaeological data confirms the existence of a developed system of fortifications and extensive settlements in Ryazan. Smolensk is depicted as a large fortress on the western borders, which corresponds to its role as a key city between Russia and Lithuania. The size of Smolensk on European maps reflects its importance as a military and trade center on the route from Moscow to Europe. Yaroslavl is shown as a significant trading city on the Volga, which corresponds to its role as an important point on the route to the White Sea and further to Western Europe. After the opening of the Northern Sea route, Yaroslavl did indeed become one of the key cities of Russian-European trade. Nizhny Novgorod is depicted as a major center at the confluence of the Volga and Oka rivers, reflecting its strategic location at the intersection of important waterways. The city was indeed an important trading hub through which goods from Asia passed on their way to Europe. A comparison with European cities reveals some interesting patterns. 16th century Paris is depicted on maps of the time as a large but not gigantic city. Its size corresponds to archaeological data and written sources. The same can be said of London, Rome, and Venice. Their depictions on maps fairly accurately reflect the reality. However, there are exceptions. Constantinople is often depicted on European maps as significantly larger than other cities, reflecting its special status as the former capital of Byzantium and the current capital of the Ottoman Empire. This shows that cartographers could indeed enlarge the size of politically important cities. It is interesting to compare Russian cities with cities of the Holy Roman Empire. Centers such as Nuremberg, Augsburg, and Cologne are depicted on maps in sizes that are roughly confirmed by other sources. But Russian cities are often shown larger than these recognized centers of European trade and craftsmanship. Polish cities, Kraków, Warsaw, Danzig, are also depicted on maps in sizes corresponding to their real significance. This is important because Poland was Russia's closest western neighbor, and information about Polish cities was well known to European cartographers. The cities of the Grand Duchy of Lithuania, Vilnius, Polotsk, Vitebsk, are shown on maps as significant centers, but their sizes do not appear exaggerated. This is interesting because many of these cities had significant Russian populations and close ties to Moscow. The Scandinavian cities of the time, Stockholm, Copenhagen, Oslo, are depicted on the maps rather modestly, which corresponds to their status at the time as centers of relatively small northern kingdoms. This shows that cartographers took into account the real political and economic significance of cities. The cities of the Hanseatic League occupy an intermediate position on the maps. Lübeck, Hamburg, and Bremen are shown as important trading centers, but their sizes are not exaggerated. This is logical, given that Hanseatic merchants were one of the main sources of information for cartographers. Italian city-states are depicted in accordance with their economic and political weight. Venice and Genoa are shown as major maritime powers, Florence as an important center of banking and the arts, and Naples as the capital of a significant kingdom. A general analysis shows that the anomaly in size is specific to Russian cities and does not extend to other regions of Europe. This suggests that the reasons for this anomaly are related to the specific characteristics of Russian lands, rather than to the general principles of cartography at the time. One of the most intriguing explanations for the abnormally large size of Russian cities on 16th century European maps is the theory of lost areas. According to this hypothesis, many ancient Russian cities were indeed much larger in the past, but over time, some of their parts were abandoned, destroyed, or absorbed by nature, which led to a reduction in their visible size. Historical sources contain numerous references to abandoned urban areas. Chronicles regularly report that after epidemics, wars, or economic crises, entire neighborhoods of Russian cities fell into disrepair. Residents abandoned their homes, wooden buildings were destroyed, and within a few decades, no visible traces remained of the once densely populated areas. Particularly devastating were the plague epidemics that regularly struck Russian lands in the 14th to 16th centuries. According to chronicles, the Black Death of 1348 to 1351 wiped out up to a third of the population of some cities. Subsequent epidemics in 1420, 1500, and 1547 also led to mass deaths and the desolation of entire areas. Military destruction also played a significant role in the reduction of urban areas. Invasions by nomads, civil wars, and conflicts with Western neighbors regularly led to the destruction of urban suburbs. Recovery from such destruction often took place not in the former locations, but in more protected areas closer to urban centers. Economic crises led to the migration of people from less prosperous areas of the city to more promising ones. Trade routes could change, craft industries moved, and entire neighborhoods gradually fell into disrepair. Wooden houses quickly deteriorated without constant maintenance, and within a generation, no traces remained of the former neighborhoods. Climate change could also affect the size of cities. The Little Ice Age, which began in the 14th century, led to cooling and worsening conditions for agriculture. This could have forced the population to concentrate in more compact, easier-to-heat areas, leaving the outskirts. Hydrological changes posed a particular problem for Russian cities, many of which were located in river floodplains. Changes in river courses, flooding, and swamping could make some areas uninhabitable. Archaeological research shows that many ancient Russian settlements were indeed flooded or swamped as a result of natural changes. The peculiarities of ancient Russian urban planning contributed to the rapid disappearance of abandoned areas. Unlike Western European cities with stone buildings, Russian cities were built mainly of wood. Wooden structures quickly decayed without maintenance, and after a few decades, no visible traces remained on the surface. Archaeological data confirmed the existence of extensive cultural layers far beyond the boundaries of modern urban centers. In Moscow, for example, traces of medieval buildings have been found in an area several times larger than the historic center. Many of these finds date back to the 15th to 16th centuries. Analysis of soil layers shows that in significant areas around ancient cities, the soil has characteristics typical of long-term anthropogenic impact. This suggests that these lands were inhabited and cultivated for a long time, although they now look like wasteland or agricultural land. Toponymic studies also support the theory of lost areas. Many names of tracts, fields, and forests in the vicinity of ancient cities contain roots associated with urban activities, such as Kuznikov, blacksmith, Gonchary, potter, Torgovo, trade, and Tsarkovishche, church. These names may have been preserved from the time when these territories were part of the city. A comparison with Western European cities shows that the phenomenon of urban shrinkage was not unique to Russia. Many European cities also experienced periods of decline when their size was significantly reduced. However, stone buildings were better preserved and allowed for a more accurate reconstruction of their former size. Documentary evidence of the layout of Russian cities often mentions areas that have since disappeared. 16th-century land registers contain descriptions of streets, churches, and courtyards that cannot be located within modern cities. Perhaps these objects were located in areas that were later abandoned. The theory of lost areas explains not only the overall size of cities, but also their internal structure. European maps often show Russian cities as consisting of multiple concentric rings of fortifications. This structure may have reflected the actual situation during the period of maximum development of cities, when each ring protected a specific historical stage of growth. However, this theory faces certain difficulties. First of all, the complete disappearance of large urban areas should have left more visible archaeological traces. In addition, the simultaneous reduction in the size of many Russian cities requires an explanation of the general reasons for such a large-scale process. Climate change in the late Middle Ages and early modern period may have had a significant impact on the size and structure of Russian cities. The Little Ice Age, which began in the 14th century and reached its peak in the 16th to 17th centuries, radically changed living conditions in the northern regions of Europe, including the Russian lands. The cooling led to a shorter growing season and lower crop yields. This forced the population to concentrate in larger settlements, where it was easier to organize joint food storage and mutual assistance in difficult times. Many small villages and settlements were abandoned by their inhabitants, who moved to large cities. Changes in precipitation patterns also influenced urban development. Increased snowfall in winter and more frequent spring floods altered the hydrological regime of the rivers on which Russian cities were built. Some areas of cities could become unsuitable for permanent residence due to regular flooding. The deterioration of climatic conditions stimulated the development of handicraft production in cities. When agriculture became a less reliable source of livelihood, many people turned to crafts and trade. This led to an increase in the urban population and the expansion of craft quarters in Russian cities. Changes in trade routes associated with climatic factors also influenced the development of cities. The freezing of some waterways for longer periods could change the direction of trade flows. Cities located on new trade routes could grow rapidly, while others fell into decline. The need for more efficient heating in colder conditions influenced urban planning. Wooden houses were built more compactly, and neighborhoods became more densely built up. This could create the impression of larger cities with the same population. The development of technologies related to adaptation to the cold climate stimulated the growth of certain crafts. The production of warm clothing, improved stoves, and more sophisticated construction technologies all required the concentration of skilled workers in cities, which contributed to their growth. Climate change influenced military affairs and, accordingly, the development of urban fortifications. Longer and harsher winters made military campaigns more difficult, giving cities more time to build and improve their defenses. Stronger fortifications, in turn, attracted people seeking protection. Changes in agricultural practices caused by climatic factors could influence the size of urban areas. The transition to more intensive farming required more agricultural tools and other products made by urban craftsmen. This stimulated the growth of craft production and, accordingly, the expansion of cities. The demographic consequences of climate change were particularly noticeable in northern regions. Famine and disease associated with crop failures could lead to significant fluctuations in population size. During periods of relative climate improvement, cities could grow rapidly, as was observed in the 16th century. Paleoclimatic data show that the 15th and 16th centuries were a period of relative climatic stability after the sharp cooling of the 14th century. This may have been a time of recovery and growth for cities whose sizes were recorded on European maps. Changes in river ice conditions affected trade and transport. Longer ice periods may have contributed to the development of land trade routes, which strengthened the role of cities located at road junctions. Moscow, located at the center of a river and road network, may have benefited particularly from such changes. Archaeobotanical studies show changes in the composition of vegetation around ancient cities in the late Middle Ages. The emergence of new species of cultivated plants adapted to a colder climate may have contributed to the development of urban gardening and the expansion of suburban areas. The influence of climate on building technologies was also significant. The need for warmer and more durable dwellings stimulated the development of new construction methods. Cities where the best craftsmen were concentrated could attract people from large areas. Changes in river systems associated with climatic factors could lead to the formation of new waterways, or, conversely, to the shallowing of existing ones. This affected the transport accessibility of cities and their economic development. Analysis of tree rings from archaeological finds shows that the period from the late 15th to the mid-16th century was characterized by relatively favorable conditions for growth. This may have contributed to a construction boom in Russian cities, traces of which were reflected on European maps. Social adaptations to climate change also influenced urban development. The creation of more complex mutual aid systems, the development of craft guilds, and the strengthening of the role of the church in social organization all required a more complex urban infrastructure and may have contributed to the growth of cities. However, the climatic explanation has its limitations. Similar climatic changes occurred in Western Europe, but there we do not see similar anomalies in cartographic images of cities. This suggests that climatic factors may have reinforced other causes, but were unlikely to be the only explanation for the phenomenon. The system of military fortifications in Russian cities in the 16th century was one of the most advanced in Europe, and it was precisely these defensive structures that could have given European observers the impression of huge urban complexes. The scale and complexity of Russian fortifications were truly impressive to contemporaries, and could have served as the basis for depicting cities in an enlarged form on maps. The concentric defense system of Russian cities involved the creation of several rings of fortifications. In the center was the Kremlin, a stone fortress with high walls and towers. Around the Kremlin, an ostrog was built, a wooden and earthen fortress that protected the commercial and craft quarters. Further out, there could be additional lines of defense, earthen ramparts with wooden palisades. Moscow was a classic example of such a system. The Kremlin occupied a relatively small area, but the total area of the fortified zone was huge. Kitai Gorod, Bely Gorod, Zemlyanoi Gorod, each ring increased the protected area. The total perimeter of all fortifications was several tens of kilometers. A distinctive feature of Russian fortifications was their adaptation to local conditions. The use of natural obstacles, rivers, ravines, swamps, made it possible to create long defensive lines at relatively low cost. These natural obstacles were incorporated into the overall defense system and visually increased the size of the protected territory. The towers of Russian fortresses were not only defensive structures, but also important architectural landmarks. The tall-hipped towers were visible from afar and gave the impression of a huge city. European travelers who saw the silhouette of a Russian city with its many towers could exaggerate its size. The system of sloboda and posad settlements around fortified centers created vast urban areas. These settlements were not formally part of the city walls, but were closely linked to the city economically and administratively. European observers could perceive the entire area as a single urban complex. The military engineering skills of Russian architects reached a high level of development in the 16th century. Complex geometric principles were applied in the planning of fortifications, and construction technologies that were advanced for that time were used. Foreign military engineers recognized the high quality of Russian fortifications. Artillery fortifications required a lot of space to accommodate guns and ammunition depots. The development of firearms in the 16th century led to the need for more extensive fortress complexes. The territory occupied by military structures increased significantly compared to previous eras. Monastery fortresses were an important part of the defensive system of Russian cities. The Trinity Sergius Lavra, the Novodevichy Convent, and the Donskoy Monastery all had powerful fortifications and controlled the approaches to the cities. These monasteries could be perceived as part of the urban complex, increasing perceptions of its size. Hydraulic structures were also part of the defensive system. Dams, canals, and artificial ponds were used to flood the approaches to the city in case of a siege. These structures required large areas and could give the impression of a large engineering complex. A comparison with European fortifications shows the uniqueness of the Russian system. Western European cities usually had a single line of stone walls that enclosed a relatively compact area. Russian cities, with their multiple rings of defense, occupied much larger areas. The peculiarities of warfare in Eastern Europe required the creation of fortifications designed to counter large nomadic cavalry armies. This involved the creation of extensive protected areas where not only the urban population could take refuge, but also the inhabitants of surrounding villages with their livestock and property. The construction of fortifications was a state task of paramount importance. The Moscow Tsars attracted the best engineers, including foreign specialists, to the fortification work. Italian, German, and English masters participated in the creation of Russian fortresses, bringing European experience to bear. Logistical support for the fortresses required the creation of an extensive infrastructure. Food and weapon depots, ammunition stores, weapon repair shops, and barracks for the garrison all took up considerable space and could be perceived as part of the city. The symbolic significance of fortifications was also important. Powerful fortresses demonstrated the strength of the state and could be deliberately built to impress foreigners. This could lead to the creation of fortifications that exceeded actual defensive needs. Archaeological research confirms the scale of Russian fortifications in the 16th century. Excavations reveal the remains of complex fortification systems that truly covered vast areas. Many of these fortifications were later filled in or destroyed, making it difficult to estimate their original size. The technical complexity of Russian fortifications amazed European military experts. The use of combined wood and earth structures, adapted to local climatic conditions, was an original solution to fortification problems. The social organization of defense also influenced the perception of the size of cities. The system of universal mobilization of the population to defend the city required the creation of extensive fortified areas where all defenders could be accommodated. This led to the construction of fortifications designed for a larger number of people than the permanent population of the city. 16th-century maps were not only geographical documents, but also important political instruments reflecting the balance of power in Europe and perceptions of the power of various states. The size of cities on maps often symbolized the political importance of countries, and it was this factor that could explain the enlarged depiction of Russian cities on European maps. In the 16th century, the Russian state was undergoing a period of rapid territorial expansion and consolidation of central power. Under Ivan III and his successors, Novgorod, Pskov, Tver, and Ryazan were annexed to Moscow. The Kazan and Astrakhan Khanates were conquered, and the colonization of Siberia began. The territory of the state increased several times over, which could not fail to impress European contemporaries. Russia's diplomatic relations with European powers in the 16th century were extremely intense. The Moscow Tsars actively sought allies against Poland, Lithuania, Sweden, and Crimea. European rulers viewed Russia as a potential ally against the Ottoman Empire. In these conditions, it was important to correctly assess the military potential of the Russian state. Russia's economic importance to Europe was also growing. The opening of the Northern Sea route through Arkhangelsk gave European merchants direct access to Russian goods, bypassing hostile Poland. Russian furs, honey, wax, and potash were important commodities on European markets. Trade routes to Persia, India, and China passed through Russia. Religion played a special role in how Europeans saw Russia. After the fall of Byzantium, Moscow claimed to be the center of the Orthodox world. For Catholic Europe, Russia was a potential ally against the Muslim Ottoman Empire, but also a source of religious competition. Renaissance cartographers were well aware of the political significance of their work. Maps were intended for kings, emperors, military leaders, and merchants, people who made important political and economic decisions. Incorrectly assessing the strength of a potential enemy or ally could have serious consequences. The principle of demonstrating power through cartography was widespread. Capital cities were usually depicted larger than provincial centers, even if their actual sizes were comparable. The political hierarchy was reflected in the cartographic hierarchy, which helped map readers correctly assess the relative importance of different territories. Competition between European powers for influence in Eastern Europe required an accurate assessment of Russian potential. Poland, Sweden, and the Holy Roman Empire were all interested in correctly understanding the strength of their eastern neighbor. Underestimating Russian power could lead to strategic mistakes. Information warfare was also waged through cartography. Depicting enemy cities as powerful fortresses could serve as a justification for one's own military failures or as a reason for large-scale military preparations. Maps were used to convince allies of the seriousness of the threat. The commercial interests of cartographers and their clients also influenced the depiction of cities. Merchants were interested in making potential markets look large and promising. Exaggerating the size of Russian cities could stimulate trade expansion in the East. Prestige considerations played an important role in cartography. Cartographers working for rulers had to demonstrate the breadth of their patrons' horizons and the importance of their international connections. Depicting distant and powerful countries enhanced the prestige of the map's patron. The scientific ambitions of Renaissance cartographers also influenced their work. Demonstrating knowledge of distant territories enhanced the scientific authority of the author. Detailed depictions of Russian cities showed the breadth of the cartographer's geographical knowledge. Military and strategic considerations required an accurate assessment of the defensive potential of cities. The size of a city on a map often correlated with the size of its garrison and supplies. Military planners used this information to calculate the forces needed for a siege or defense. Dynastic ties between European and Russian ruling houses also influenced cartography. Marriages between Russian princesses and European princes and diplomatic negotiations on possible alliances created a political context in which Russia had to appear a worthy partner. The Protestant Reformation changed the religious and political map of Europe and increased interest in Orthodox Russia as a potential ally against Catholicism. In this context, demonstrating Russia's power and importance through enlarged images of its cities served the political interests of Protestant countries. The Ottoman threat united Christian Europe and made Russia a valuable ally in the fight against Muslim expansion. Cartographic emphasis on Russian power served as a justification for the need for an alliance with its eastern neighbor. The colonial expansion of European powers in the 16th century created a need for global thinking. Russia was seen as the key to Asian markets, and its cartographic representation had to reflect this role. The Renaissance intellectual fashion for exotic countries and peoples may also have influenced the image of Russia. Distant and mysterious Muscovy had to look appropriately impressive to satisfy the curiosity of the European public. Modern science has an arsenal of methods that allow us to take a fresh look at the mystery of the size of Russian cities on 16th-century European maps. Archaeology, historical geography, paleoecology, and digital reconstruction technologies all contribute to our understanding of the real picture of the past. Geographic information systems have revolutionized the study of historical topography. By superimposing old maps onto modern satellite images, it is possible to determine with high accuracy the correspondence between historical images and real geographical objects. Such analysis has shown that many details of 16th-century European maps correspond surprisingly accurately to reality. LIDAR surveying has opened up new possibilities for detecting hidden archaeological sites. This method allows us to see through vegetation and detect the remains of ancient structures that are not visible on the surface. In the vicinity of Russian cities, LIDARs have discovered traces of extensive settlements that may have existed in the Middle Ages. Dendrochronological studies provide accurate dating of wooden structures found during archaeological excavations. Analysis of annual rings allows not only to determine the time of construction, but also to reconstruct the climatic conditions of the past that influence the development of cities. Paleosol studies help reconstruct the history of land use in the vicinity of ancient cities. Analysis of soil layers shows where and when agricultural activities took place, allowing estimates of population density and the size of economic areas. Isotope analysis of archaeological finds opens up new opportunities for studying trade links and population migrations. The isotopic composition of metal objects can be used to determine where they were made, while analysis of human and animal bone remains reveals their origin and diet. Digital reconstruction of historical landscapes allows the creation of three-dimensional models of ancient cities based on archaeological data and written sources. Such models help to understand what a city looked like in the past and what impression it might have made on contemporaries. Statistical analysis of cartographic data reveals patterns in the depiction of cities on old maps. Comparing the sizes of cities on maps by different authors and from different periods allows us to identify general trends and deviations from them. Computer modeling of urbanization processes helps us understand the factors that influence the growth and development of medieval cities. The models take into account geographical, climatic, economic, and political factors, allowing us to assess the likelihood of various development scenarios. Archaeogenetics opens up new opportunities for studying ancient populations. Analysis of DNA from archaeological burials allows us to reconstruct migration processes, the ethnic composition of populations, and kinship ties between different groups of people. Interdisciplinary research combines methods from various sciences for a comprehensive study of historical problems. Collaboration between archaeologists, historians, geographers, climatologists, and computer technology specialists provides a more complete picture of the past. International research projects allow for the comparison of data from different regions of Europe. The study of urbanization processes in Russia, Poland, Germany, and Scandinavia reveals common patterns and regional characteristics of urban development. Archival research using new text processing methods is opening up previously unknown sources of information. Computer analysis of large document collections allows us to identify hidden connections and patterns that were not apparent in traditional source studies. Experimental archaeology helps us understand the technologies of the past. The reconstruction of ancient methods of construction, crafts, and transportation allows us to assess the real possibilities and limitations of medieval society. Ethno-archaeological research studies traditional societies to understand the processes that took place in the past. Comparisons with modern analogs help interpret archaeological data and reconstruct the way of life of ancient people. Space archaeology uses satellite images to search for archaeological sites. Changes in vegetation, soil cover, and relief can indicate the presence of ancient structures hidden underground. Virtual reality allows you to create immersive reconstructions of historical sites. Virtual tours of ancient cities help to better understand their layout, architecture, and the daily life of their inhabitants. Crowdsourcing in archaeology involves volunteers in the processing of archaeological data. Thousands of enthusiasts around the world help analyze satellite images, classify finds, and digitize archival documents. Artificial intelligence is beginning to be used to analyze historical data. Machine learning helps identify patterns in large data sets, automatically classify artifacts, and recognize images on old maps and pictures. The results of modern research show that the problem of the size of Russian cities on 16th-century European maps is much more complex than previously thought. Simple explanations are not enough. A comprehensive approach is needed that takes into account many factors and uses the entire arsenal of modern scientific methods. The revolution in technologies for studying the past has opened up unprecedented opportunities for investigating the mystery of the size of Russian cities on 16th-century European maps. Modern methods allow us to literally look into the past and see what was hidden from previous generations of researchers. Georadar surveying is a non-invasive method of detecting underground structures. Radio waves penetrate the ground and bounce off various objects, creating a detailed picture of the subsurface layers. Using ground-penetrating radar, archaeologists have discovered traces of extensive settlements that existed in the Middle Ages in the vicinity of Russian cities. Magnetometric surveying detects anomalies in the magnetic field caused by the presence of archaeological objects. Furnaces, hearths, metal objects, and burnt clay create characteristic magnetic signatures. This method allows archaeological sites to be mapped over large areas without excavation. Electrical prospecting uses differences in the electrical conductivity of soils and archaeological objects. Stone foundations, filled-in ditches, and ancient roads have different electrical conductivity compared to the surrounding soil. This method is particularly effective for detecting the remains of stone structures. Spectral analysis of satellite images allows archaeological objects to be detected by changes in the reflectivity of the surface. Different types of soil, vegetation, and moisture create characteristic spectral signatures that can indicate the presence of hidden archaeological structures. High-resolution photogrammetry creates detailed 3D models of the terrain based on aerial photographs. This technology allows the detection of micro-relief associated with ancient structures and the accurate mapping of archaeological sites. Laser scanning creates highly accurate 3D models of objects and terrain. Ground-based laser scanning is used to document architectural monuments, while airborne laser scanning is used to map large areas with sub-meter accuracy. Multispectral imaging records light reflection in different parts of the spectrum that are invisible to the human eye. Infrared, ultraviolet, and hyperspectral imaging reveal details hidden from normal observation, including traces of ancient structures and roads. Thermal imaging detects differences in the thermal properties of the surface. Stone structures, underground cavities, and filled-in ditches have different thermal conductivity and create characteristic thermal anomalies, which are especially noticeable at certain times of the day. Chemical analysis of soils reveals traces of human activity in the past. Elevated phosphorus content indicates places where people and animals lived. The presence of metals indicates craft activities, and changes in the composition of organic substances indicate agricultural use of the land. Palynological analysis studies pollen and plant spores preserved in soil deposits. This allows us to reconstruct the vegetation of the past, determine when forests were cut down for urban construction, and identify periods of intensive agricultural development of the territory. Radiocarbon dating accurately determines the age of organic materials. Modern methods allow samples several hundred years old to be dated to within a few decades, which is critical for the study of medieval cities. Dendrochronological dating is based on the analysis of tree rings. Unique sequences of wide and narrow rings allow the exact year of tree felling to be determined and past climatic conditions to be reconstructed. Archaeozoological analysis studies animal bones from archaeological layers. This provides information about economic activities, trade links, climatic conditions, and population density in ancient cities. Ceremological analysis examines fragments of pottery, which are the most common finds in archaeology. The manufacturing technology, clay composition, and ornamentation can be used to determine the time of manufacture, place of production, and cultural traditions. Metallographic analysis studies the structure and composition of metal objects. This makes it possible to determine ancient metallurgical technologies, sources of raw materials, trade links, and the level of development of crafts. Petrographic analysis studies stone artifacts and building materials. Determining the mineral composition allows us to establish the places where the stone was quarried, trace trade routes, and understand construction techniques. Stratigraphic analysis studies the sequence of archaeological layers. Accurate recording of the relative positions of finds allows us to reconstruct the chronology of events and understand the development of settlements over time. Planographic analysis studies the spatial distribution of finds in archaeological layers. This helps to understand the layout of ancient settlements, the functional zoning of the territory, and the characteristics of the buildings. Statistical analysis of large archaeological data sets reveals patterns that are not noticeable when studying individual monuments. Computer processing allows information from hundreds of excavations to be compared and common trends in urban development to be identified. Digital restoration of historical documents restores damaged maps and texts. Special algorithms can recreate lost fragments based on surviving parts and general principles of creating similar documents. Computed tomography is used to study archaeological finds without destroying them. This method allows us to see the internal structure of objects, discover hidden details, and determine the manufacturing technologies of ancient artifacts. Neural networks are trained to recognize images on historical maps and images. Artificial intelligence can automatically identify cities, roads, rivers, and borders on thousands of old maps, which greatly speeds up their analysis and comparison. Virtual archaeology creates digital copies of archaeological sites and finds. Three-dimensional scanning allows accurate information about objects to be preserved and made available to researchers around the world. Historical process modeling uses mathematical models to understand the factors that influence the development of cities. Computer simulations help test various hypotheses about the causes of the growth or decline of settlements. The results of applying modern technologies to the study of Russian cities are surprising. Many technologies confirm that medieval Russian cities could indeed have been much larger than previously thought, which gives new meaning to the evidence provided by 16th-century European maps. In addition to traditional historical approaches, there are a number of alternative theories that attempt to explain the anomalous sizes of Russian cities on 16th-century European maps. Although these hypotheses are controversial in the academic community, they offer unconventional perspectives on the problem and deserve careful consideration. The theory of chronological shifts suggests that traditional historical chronology may contain errors, and events that we attribute to different periods may have actually occurred simultaneously or in a different sequence. According to this hypothesis, the sizes of cities on 16th-century maps may reflect a later period of their development, mistakenly attributed to an earlier time. The alternative geography hypothesis asserts that the geographical location of some historical objects may have been misinterpreted by modern researchers. It is possible that European cartographers depicted not the cities that we identify today with their names, but other settlements located in different places. The theory of hidden sources suggests the existence of historical documents that have been lost or are inaccessible to modern researchers, which could shed light on the real sizes of ancient cities. These sources may have been destroyed as a result of wars, fires, social upheavals, or deliberately concealed for political reasons. The concept of the medieval climate optimum considers the possibility that climatic conditions in the past were significantly more favorable than is commonly believed. This could have contributed to more intensive urban development, traces of which were subsequently lost due to climate deterioration. The technological loss hypothesis suggests that construction and urban planning technologies may have existed in the past that were subsequently forgotten or lost. This could have allowed for the creation of larger urban complexes than seems possible based on our understanding of medieval technology. The demographic explosion theory considers the possibility that the population of the Russian lands was significantly higher than traditional historical sources indicate during certain periods. High population density could have provided the labor force for the construction of large cities. The concept of economic prosperity suggests that the economy of the Russian principalities may have been significantly more developed than is commonly believed. Intense trade, developed crafts, and efficient agriculture could have provided the resources for the construction and maintenance of large cities. The social organization hypothesis considers the possibility that more efficient forms of social organization existed in the past, which allowed for the mobilization of large resources for urban construction. Such forms of organization could have been subsequently destroyed by social upheavals. The theory of religious motivation suggests that the construction of cities may have been linked to religious beliefs and practices that encouraged the creation of large urban complexes as embodiments of the heavenly Jerusalem on earth. The concept of military necessity considers the possibility that the geopolitical situation in the past required the creation of larger and more powerful urban centers to defend against external threats. These threats may have been more serious than traditional historical sources reflect. The cartographic traditions hypothesis suggests the existence of special principles for depicting cities in medieval cartography that are misunderstood by modern researchers. Perhaps the sizes of cities on maps did not reflect their physical parameters, but rather other characteristics, symbolic, economic, or political. The theory of information distortion considers the possibility of systematic errors in the transmission of information between different cultures and eras. These distortions could accumulate and lead to the formation of incorrect ideas about the past. The concept of selective preservation of sources suggests that mainly sources of a certain type have survived to the present day, which give an incomplete picture of the past. Sources that could confirm the large size of ancient cities may not have survived or may be inaccessible to researchers. The political censorship hypothesis considers the possibility that information about the actual size and power of Russian cities was deliberately distorted or concealed in later historical periods for political reasons. Such censorship could have distorted our understanding of the past. The theory of archaeological gaps suggests that many important archaeological sites have not yet been discovered or properly studied. Future discoveries could radically change our understanding of the size and development of ancient cities. The concept of interdisciplinary misunderstanding considers the possibility that the correct interpretation of historical data requires knowledge and methods from different fields of science that have not yet been properly integrated. Despite the controversial nature of many alternative theories, they serve an important function by stimulating critical rethinking of established ideas and the search for new approaches to studying the past. Some of these ideas may prove fruitful and lead to new discoveries in historical science. After a detailed examination of all possible explanations for the mystery of the size of Russian cities on 16th-century European maps, we can attempt to synthesize the most likely solution to this historical puzzle. The truth, as is often the case with complex historical questions, lies not in a single cause, but in a combination of multiple factors. First of all, modern archaeological research convincingly shows that Russian cities were indeed much larger than assumed in traditional historiography of the 19th and 20th centuries. Cultural layers discovered far beyond the historical centers indicate that the built-up area exceeded modern estimates several times over. The system of concentric fortifications characteristic of Russian cities created vast protected areas that were perceived by contemporaries as a single urban complex. The Kremlin, posads, sloboda settlements, and fortified monasteries formed an interconnected system, the overall size of which could indeed impress European observers. The peculiarities of Russian urban planning, based on wooden architecture and adapted to local climatic conditions, allowed for the rapid expansion of urban areas. Wooden houses were built much faster than stone ones, which made it possible to develop large areas in a relatively short time. Russia's economic prosperity in the 15th and 16th centuries, linked to its advantageous position at the crossroads of trade routes between Europe and Asia, provided resources for large-scale urban construction. Income from transit trade, the sale of raw materials, and craft production made it possible to maintain large urban centers. Political factors also played an important role. The centralization of power in the Russian state required the creation of powerful administrative centers. As the capital of a rapidly growing empire, Moscow had to live up to its status, which stimulated its active development. Military and strategic considerations dictated the need to create large fortified complexes capable of protecting not only the permanent population, but also the inhabitants of the surrounding areas during enemy invasions. This required the construction of extensive defensive systems and the corresponding infrastructure. Demographic processes in the late Middle Ages contributed to the concentration of the population in large cities. The unification of the principalities under the rule of Moscow led to the migration of the population to the capital and other important centers, which stimulated their growth. Religious factors added a symbolic dimension to urban construction. As the Third Rome, Moscow had to look worthy of its status as the center of the Orthodox world, which required appropriate architectural expression. The information processes of the 16th century provided European cartographers with fairly accurate data on Russian cities, developed trade, diplomatic, and cultural ties, created multiple channels for the transmission of information, allowing cartographers to obtain reliable data. The quality of European cartography at that time was high enough to ensure a relatively accurate representation of geographical features. Renaissance cartographers were professionals who used the most advanced methods of their time. The climatic conditions of the 15th and 16th centuries were relatively favorable for the development of cities. The period after the end of the acute phase of the Little Ice Age created conditions for economic growth and demographic rise. However, over time, many factors that contributed to the growth of cities changed. The political upheavals of the 17th century, changes in trade routes, wars, and epidemics led to a reduction in the size of many cities. Wooden buildings quickly fell into disrepair without proper maintenance, and traces of former grandeur disappeared. The historiographical traditions of the 18th and 19th centuries, which were shaped by certain political and ideological attitudes, may have underestimated the achievements of previous eras. This led to the formation of perceptions of Russian cities as relatively small settlements. Modern research technologies allow us to take a fresh look at this problem and confirm much of the evidence provided by old maps. Archaeology, geoinformatics, and interdisciplinary research are opening up new facets of historical reality. Thus, the mystery of the size of Russian cities on 16th-century European maps can be explained by a combination of real historical factors and the perceptions of these cities by their contemporaries. The maps reflected a reality that was more complex and larger in scale than historians of later centuries had imagined. This story reminds us that the past can hold surprises, and established ideas always need to be critically examined. Each era interprets the legacy of its ancestors in its own way, and our task is to strive for the most objective understanding of historical truth.